everyone, I'm Dave Harris and I am going to talk about the Midhants Railway's model railway in a van. So the project started back in 2009, got completed in about 2012, and it was a big team effort involving the Midhants Railway, who owned the van, the Midhants Railway Wagon Group, who renovated the van, and also provided the chippies for building the baseboards, and the Basingstoke and Northants Model Railway Club, who provided the expertise on the model railway, and myself and Rob Score, who did the electronics. Oh, and it says it all here. And yes, it should be easy putting a model railway into a railway van. We had a few hiccups which I'll go through across the way and talk you through it. As I say, the team was quite big. There were probably 6 people on the wagon itself, another 6 people on the scenics and track laying and all that, and 2.5 people on the electronics, half being somebody was half time. So what the Midhants Railway wanted, because they were funding the whole project, was something that looked a bit like the Midhants Railway itself. And the then educational officer wanted it to have an educational feel to it. They wanted sound effects and interactive. They wanted to have the public, the children in effect, have to answer simple questions about railway operations, so that the train would only drive if they'd actually answered all of the questions correctly. So there's the rough timetable, and say Rob and I and a couple of others, we were working on this back in 2009. Went through various iterations and until we got an agreement and money was agreed. The van by that stage was pretty much, so the specification was laid out and costs agreed, and because it's on the Midhants Railway, they wanted it to look a bit like the Midhants Railway. So the basic plan was that the single track line would run between Medstead and Ropley, and if people know that line, it runs through rolling hills and beautiful countryside. It's nicknamed locally as the Alps. I think you've all had a chance to read that now, so I'll move on. Yeah. There was the timetable. The by 2011, the van, the PMV van, had been restored, and the carpenters could actually set to with the cutting up of the baseboards. Now, when I say baseboards, these are heavy duty baseboards. A van like that, when it's trundling around the railway at top speed of 25 miles an hour, whatever it is, on fairly shoddy track at places, the sides of the van don't half sway a lot, and everything has to be built strong. very strong. The layout in the meantime was being built in Basingstoke, and the van was at Ropley. And so we actually, because it's 38 foot long, we had just enough room to get probably 3/4 of the layout erected in the club rooms so that we'd actually work on it. So we never actually got to run it fully until we transported it down to Ropley and installed it in the van. So that was quite interesting. The carpenters then did a fabulous job of keeping the little children's fingers out of the layout with surrounds and glazing. And it's at that time we started finding the bugs in the layout. And I'll come on to those in a bit. And yeah, come 2013, it was all up and running. Sorry, I'll move 2 pages there. So that was the van in its early days, had no floor. The van was basically floating on its metal stanchions, and a fair amount of rust, so it was swaying quite a lot. That's the van in its resting place at Ropley in its pristine painted condition. So there's the first view of the layout inside the van, and you can see the heavy duty baseboard framings with the baseboards mounted on top of the framings. One thing you don't do in a model railway van is you don't attach anything to the walls, because the walls flex. The whole body of the van sways. So if you have anything screwed to the walls, the motion will go through to the baseboards. So the whole thing's freestanding. We had grand ideas at the beginning to have the legs bolted into the floor of the van. But as you can see, those baseboards weigh a ton, and actually we just let gravity do its work. Although I believe at the end we actually put some blocks down towards the end plates of the van, so that in a heavy stop shunt, the layout wouldn't tend to slide along the floor of the van. These posters along here, they came from the National Railway Museum for an exchange of money between the Midhants Railway and the National Railway Museum, and they really do set the layout off. Okay, here's the plan of the van and the layout. It's a dogbone plan. Now, if you look at the track plan, you'll see that there is only one direction of travel at each end of the layout. You've got a pair of platforms, so you always go around the loops at the end in the same direction. The bit of the layout which is reversible is the single line track between the two stations, which is an interesting point when it comes to the electronics. The only place you actually have to have reversal of power is on that single line section in the middle. The signals are all working signals, because, as I said, the Midhants Railway wanted questions to the children like, you can't drive a train until the signal's raised or lowered, depending if it's upper or lower case. Yeah, you know what I mean. Lots and lots of trees were made. The old seagrass and hebe. So this is a picture of Medstead Wood. Doesn't exist on the Midhants Railway. Medstead Station got renamed to Medstead Wood because it was only partially like Medstead. Okay, right, the electronics. So 11 microprocessors. It doesn't half add up quickly. So we got the traction pick. All these processors are microchips pick processors. So there's one for traction, another one for the control of all the point signals and switching the traction power on and off and the sections. Then another one which is connected by an RS-232 cable to the previous panel, is where the lights and push buttons are there for the public interaction. And then there are 8 infrared detectors around the layout, and the white lights you can see on this panel show you the sections are occupied at IR2, IR1 and IR3, IR being infrared. And there are no yellow lights lit, so there are no sections energized in this picture. So there are 3 trains standing on the layout, and the design of the electronics is such that it'll work with 2 or 3 trains. The software is designed so that it's always looking for the empty platform. In this case, the empty platform is IR4, therefore the only move possible is IR3, section 3, moving to section 4. When that move completes, then the empty section will be section 3. The only possible move then would be out of section 2 down the single line into section 3. So at the end of every move, the computer goes through, works out what it can and can't do. We never did bother with having just one train in motion on the layout. It seemed a bit pointless, so the software is 2 trains or 3. We couldn't let the software determine how many trains it had, because it's quite easy to get false detects, and you would get the situation where the false detect would get the computer doing some randomly stupid things. So the computer is actually told how many trains it's got, and it has to match the number of sections it sees to that count of trains. What you can see at the top right there is the traction speed setting. So there is slow, normal and fast, or as some people call it, ramming speed. A train movement, and that's a binary code that you can see at the top right there, will start a train moving by ramping the speed up on pulse width modulation until it gets to speed setting 1, and then it will stick there. So you should see a train gradually pull out until it gets to its slow cruise speed. And what would happen then is that the next train on track sensor would then trigger the speed to go up to either 2 or speed 3. We found early on that you can't do speed 3 round the reversing loop at the end because they're fairly sharp radius. So on the single line section, you can get up to speed 3, but on the end loops, you leave the speed at maximum of 2. In there, that box there is the direction of travel. These two boxes have got red LEDs for error conditions coming out of what we call the sequence pick, which is the one that controls all the sequences, or the traction pick, which controls the pulse width modulation and overcurrent sensing. And that one there is simply, we've got 12 volts on the system. The infrared detectors. Now, my big failure here, this infrared detector is my own design. That chip there is the sensor from a TV remote control. 38 kilohertz modulation infrared. And in tests, it worked a treat, absolute treat, because inside that package is the IR transistor, amplifiers, filters, and comparator, and it produces a lovely signal out on the 3rd pin of that package. Perfect, I thought, absolutely perfect. When it went under the layout, we got inconsistent operation, and what we eventually found through lots of reading and stuff like that was it was that chip which was the at fault. The PIC there, microprocessor, is a 16F505, coded in C, and produces an output. That connector there is also the ICSP programming port. So when you unplug this from the layout, you plug a cable in there and you can program the PIC. And that there is a 5-volt regulator. That there is the infrared emitter. And that's the LED that says it's working. But as I say, it didn't quite work. Loads of problems. Black plastic absorbs infrared. It does not reflect it very well. You try Googling it. Black plastic really does absorb it. Reflective plastic tape was sort of okay, but it had its problems. And then we had a problem with delay in the detector, and depending on the loco type, we would get overshoots from the sensor. We tried using red tape on the underside of the loco, but the one that worked was white plastic strip, which would be blue tacked on the underside of the loco, so that it was just in between the wheels and not impeding the motion of the wheels. Right, what we found was that the TV remote control chip was picking up RFI from the tracks immediately above it. So all those little sparks and spikes of energy coming off the wheels were actually getting into the chip. And if you put the chip inside a nice metal container, you could actually get the chip to work okay. But then it was impractical to mount it underneath the rails so that it could work properly. So Mark II sensor is basically a Hector, Merg Hector. At the time, the shop had run out of components, and so I lashed these up on strip board. And everything then worked okay. But that was a real painful learning exercise, going back to that infrared chip there. Okay, so the van, we realised we had to keep the children's fingers from touching it, touching the layout. So our original idea was this, and I can't remember why we didn't end up with that, but in the end, we ended up with these big glazing panels held in with these clips. And it really did give a better viewing job of the layout. The big downside of these big glass panels, which are laminated, was children's fingerprints, ice cream prints, sweet prints all over the glass. So daily, when you're operating this, you have to go around and polish all the glass to get the kids' handprints off it. Okay, this here is the fledgling interactive control panel. And this here is the sequence control panel. That's the brain of the whole thing. Everything's coded in C. And the two panels are connected by an RS-232 cable, so that this panel, the public panel, gives an OK to the sequence panel to run trains. This panel's got an annoying buzzer in it, because if you get a derailment, if you get a stalled train, it's got a buzzer inside it so that it tells you that things aren't happening right. With any model railway, track cleanliness is very important. The idea of this panel is it would have a whole series of buttons and questions and LEDs. And once you got all the LEDs lit, that would signal then to this panel to drive the next train, because the children had answered the questions correctly. There's the final panel with its overlay, and there's the buttons and the lights, and the electronics are all stuffed inside. There's two loudspeakers in there. The questions were verbal, so they emit from those loudspeakers. And I must admit, I wasn't really too involved with that panel. I designed the electronics, but the questions and answers were all designed by Rob Score and the Midhants Education Director. So it's got a sound chip card in there and a PIC processor driving the sound chip card. Well, there's the sound cards, and there's the PIC processor. And somewhere in there is power supply and the 2 speakers. So there's your buttons and the lights. So basically, yeah, the panel would determine the next train to run. Right, so railways are dangerous places. We had the van heavily shunted once, which is, I think, when we ended up putting a few bolts into the floor to stop the layout sliding much. The heaters, we had to put heaters in to keep the damp out, because you can see it in the scenery, the glue unbonding from trees and buildings and things like that. The ship to shore supply was also a big pain. To get mains into the van, you had a big long extension cable running out. Sometimes operators would just sling the cable across the rails, with the obviously fatal result that could come up with, or it was laid next to a cable trough which one day burnt out, and our cable burnt out with it. So it was a difficult job keeping the damp out of that van. The dehumidifiers were the final item to go in, and they would clear a lot of the moisture out of the air. The other thing about the damp is the nickel silver rails tarnish very quickly. And so after a period of storage over winter, you really would have to scrub the rails to get them bright and electrically conductive again. The ship to shore supply was also a problem. When the van was shipped to, shunted across to Alresford, the only place we could show the layout was at the cattle dock at Alresford station. So an engine would come along, drag the van from Ropley all the way up to Alresford and put it into the cattle dock. The shore supply was then run out into the nearest socket, which was the restaurant storeroom. And people in the restaurant would see this cable and think, what the hell's that? Unplug it and plug in toaster or whatever it was they were trying to plug in. So that caused us a few troubles as well. There's the pretty much the finished effect with the spotlights in and wired. The back scenes have got clouds on, and the trains were running nicely. Right, to the schematic of the layout. So here is our dogbone track plan, and here are our sections: section 1, section 2, section 5 left, 5 right, and that's the center line of the layout there. And then section 3 and section 4, and each section's got its own sensors. So sensor 4.1, 3.1, and there are 4 home signals. And bear in mind that this part of the layout is off scene. Likewise, this part of the layout is off scene. So there's no starter signal on this platform, and there's no starter signal on this platform because they're off scene. So that left us with the home signals here, here, and starter signals there and there. The electrical sections are driven by relays, which are shown here. This center section was split in two just to make it easier for wiring up and testing. So relay 5L and relay 5R actually operate on the same signal, but physically separate. So we didn't actually have to put any traction current jumpers across the middle here. Just made testing a whole lot easier. We could test the half a layout. So the traction bus, pulse width modulated, is 12 volts PWM running at about 20 kilohertz. I think, off memory. Might be some other frequency, but anyway, there you go. And then you've got the data buses and power buses, which run down these RS-232 cables, repurposed by cutting the ends off where necessary and wiring them up to tag strips. So the modules, we have a servo 4 here for operating the 2 signals and the 1 turnout. And at the other end of the layout, we've got another servo 4 for operating those 2 signals and that turnout. Then we've got the relay driver for relays 3, 4 and 5 there, and relay driver for relays 1, 2 and 5L there. And then we've got some buffer chips there and there for the infrared sensors to drive some current down the bus. Here is the traction pick, 16F88. This is all very old school stuff. The traction pick has also got an output so that when the signal, the PWM, is accelerating, it causes a sound clip to play, which is chuffs. That was all very good until we ran for diesel galas and we had chuffing diesels, which, yeah, eventually when the sound clip broke down, we never bothered to repair it. And then there's a loudspeaker at one end of the layout and down at the other end of the layout. It always was a bit disconcerting because you'd be up this end of the layout and you'd hear the chuffs, but the actual engine was down here moving. So there you go. It was built on a cheap budget. The red wire here is the 12 volt supply going round the layout, and the black wire is the logic signals. So we come down then to what we call the maintenance panel, which has got inside it a battery, an SLA battery. This got us round the problem with shore supply disappearing. If the power was pulled when it was in moving a train, when the power is restored, the panel would see insufficient trains and alarm. So we needed a clean shutdown if the power got disrupted, because otherwise you have to pull all the glass off the display cabinet to drag the train back to a safe starting point. So the use of an SLA battery allowed us to shut down gracefully. In fact, I never actually wrote the code for a shutdown gracefully. The battery would run for about 6 or 7 hours with no juice going in. And I just lost the will to live then to actually do the shutdown gracefully. The battery just kept it going. Battery charger, topping up the 13.8 volts DC into the battery, circuit breaker, on-off key switch, and then the layout power up relay. So that it was under software control, we could actually shut down the whole layout when there was an irritating alarm going off and we were trying to find out where it was, and or if there was smoke coming out somewhere, we could shut down the whole layout from the control panel. And for some reason I wanted to leave the what I call the sequence pick operational. Again, this is another old school 16F877 chip. They were the cheap chips of the day. And the alarm sounder, which is basically a transistor driving a piezo sounder. And an RS232 converter, which drove across to the public panel. And here is the mimic panel and the control switches, it going into the sequence pick. The sequence pick drove a transistor which drove the power on, power off relay. Onwards to the public panel. This has got another power supply, key switch, amplifiers, loudspeakers, sound chip, and the LEDs and their drivers, and the push buttons on the panel, and another RS232 converter driving into the control pick. Again, all coded in C, 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 and all functional. We didn't mind if the public panel died a death when the shore supply died. But as I say, we had to make sure that trains kept running if the shore supply stopped. So that 12 volts from the battery goes all the way around the layout, driving everything, even the traction supply. What else can I say about that? The signalling is basically TTL logic lines in a screened cable, and the sequence pick we never did get round to putting a buffer on. The sequence pick itself drives the bus lines. It works, so we never bothered to change it, even though there's 8 meters of cabling running around to the far end of the layout. And, Apologies for the scrappy bit of paper. It seems that the only copy of the schematic I've got left on my that I can find easy on my computer. This is the traction pick, 16F88 chip, a nice big chunky MOSFET, which is good for 40 amps. So basically that drives, connects 0 volts to the tracks, and the other side of the track is connected to 12 volts. The source of the MOSFET here goes through a sense resistor down to ground. That'll be a 5-volt regulator there, I think. And that's the in-circuit serial programming connector. That connector there is the output to the chuff generator, which is basically a sound clip file module. What else can I say about this? A couple of LEDs giving you status. And I think that's about it, really. Built into this chip, the overcurrent sensing takes the pulse width modulation when it senses an overload, takes it down to a 5%, I think, pulse width modulation for a duration. If that continues to show overcurrent, then it will cut the pulse width modulation off for 30 seconds or so, and then it will come back on again at 5% modulation, and till it sees the short circuit go away. If the short circuit's still there, then it will back off for another 30 seconds. And so you'll hear the alarm on the short circuit sounding, switching off, sounding, switching off. Again, all coded in C. And that trim pot there sets the lowest, sets the start voltage for speed 1, or sets the speed for speed 1. Speed 1 is the guaranteed voltage for the selected locomotives to run without stalling. Now, what we found was we had to pre-qualify all locomotive types from Bachmann and Hornby, etc. We had to pre-qualify them for their start speed and their speed running qualities. So a T9 will really take off like a bat out of hell, but it won't get going until it's got 6 volts on it. And by the time you get to 10 volts, it's going supersonic. Whereas other locos will be completely the opposite. So some locos we found we just had to bar them from the layout so that the operators would bring their own locos in. None of the locos and coaches were owned by the Mid-Hants Railway. So we had to have a pre-qualification process, and we drew up a short list of those locos which would work, and then we set that potentiometer to set that voltage for those locos to work repeatedly. Now, what you will find is that on a cold day, the locos all tend to run very slowly. And on hot days, and when the locos get warmed up, they will start to run quite fast. So it's a balancing act, setting that potentiometer to get a decent balance across the locomotives and across the days, across the day. It didn't matter when you got to speed step 2 or speed step 3 what sort of voltages it was running at. The critical one was the slow speed running. Operators would, at their own peril, try and bring their own favourite Thomas the Tank out. And I think there were 2 varieties of Thomas the Tank. One would work fine and the other one wouldn't. And I can't remember the details which one was which, but operators being operators, they would love to have their favourite Thomas out. Celebi. I have to say that the Midlands Railway brought the van out for steam galas, and Thomas days. And the big money spinner was the Thomas days. And so it was deemed correct that we would run Thomas and friends on the layout on the Thomas days. So again, the pre-qualification meant that we had to upset some operators by saying their favourite engine was barred from running on the layout. Questions?
I've got a couple of questions while people think of theirs.
Okay, far away.
Acceleration and deceleration, did you sort of try and control that within the pick for the traction power?
No, trial and error, I set up a duration, and if it looked right, it was right. And because we had no control over the rolling stock roster, it was a guess as to what acceleration and deceleration to use, but the numbers that were chosen empirically, they worked.
One more is that how accurately did it stop at the stations, Dave?
Right. Once we got the hectare units in, pretty good. Now, some locos will roll a long way even after power is killed. And it will depend on the load behind the loco, because that load will still be pushing that loco. And yes, we did get spads, but it would normally be because an operator had taken the regulation 2 or 3 Mark 1 coaches off the tail of it and put a brake van on it, or something of like that. And the qualification process of the loco included the train. So an Ivet and 2 coaches was acceptable. It could have been that a standard 5 and less than 2 coaches was unacceptable. So we had to have strict rules because the load on the loco really did affect where it stopped at.
Okay, we've got a question from James.
Far away, James.
Yes. Might you have got perhaps a little more reliability if you'd have used DCC and stay alives, which might also have helped your stopping position with back EMF? Or would that have taken the whole thing over budget?
It would have increased the complexity of the project a million times, because we had no control over the locos coming in. We'd have had to have an interface where we could say that locomotive at A and locomotive B and locomotive at C are this, this and this address. And I'm afraid the operators coming from the Midhants Railway fold were generally not that au fait with computers, DCC and things like that. To answer your question, yes, it would have been good to have done that, but it wasn't going to be possible.
We've got another question from Adrian.
Yeah, right. It was just a comment really about the chuffing, and if you use a stereo amplifier and then you use something like an audio editor like Audacity, you could fade in from left to right with the sound, or the other way, and sync it with the movement of the locos. I just wondered whether you had thought of something like that.
We had thought of many ideas around that area. The fact that every year there was a diesel gala meant the operator, because not necessarily me or myself or Rob School would be down there for a gala, would have to change the sound chip over or change the setting so that the sound chip was selected differently. And the sensors were there, we could perhaps have done it, but the fact is that we could have Thomas running at a mainline chuff or a diesel running at a mainline chuff. Really mostly killed the chuff idea.
Okay.
One more question, Dave. What was the longest sort of train that you could run on the system?
3 Mark 1 coaches and a mainline loco, because it would start to look silly with the short platforms that we were constrained by, that most of the train would be stopped with the engine not visible.
Yeah. Hi, Dave. Yes, I missed the very start of your presentation. So there was some reference to the obtaining some of the parts from the National Railway Museum, I think, or the NRM or something.
Yeah, the display boards.
Yeah. Okay. Yeah. And what was I going to ask you? Oh yes. For obviously with actually that's a perfect shot there you have now. Well, you have these glass panels in the front. So to clean the track, do you have to remove those? And where does an operator put their locomotives and coaches onto the layout? Is that done at the ends and the loops out of sight? Or?
At the platforms, the trains are loaded into the platforms. Mm-hmm. So there's a station there, Medstead. So you take out those 2 glass panels, which are held in with 4 Allen key screws.
Yeah.
And then you'd lower the glass panels to the floor carefully, and clean the tracks. Once you clean those platform roads, then you could load in the trains, and then you would put that glass back in, then move along, take the next bit of glass out, clean the track there, move on down the layout. When you got to the station over here, then you would clean the tracks and then load up the desired trains in that platform. Okay. And then you would have to go around the back of the layout there into this space here, so you could clean the reversing loops.
Okay.
Then you'd have to jump down onto the 6 foot, and then climb up here and then clean this piece of track.
Right.
Did that answer it?
It does, yeah. Very comprehensive answer, yes, indeed. Quite a big job doing all that.
Yeah, we generally, at the start of a running session in the spring or autumn, the van would be freezing cold. Even though we had heaters in there, they were only providing background heat. And so the first hour, we would put the heaters on full blast, put a fan heater in the middle here, and for an hour, we would be warming the van up and cleaning the tracks and loading up. So before opening time at 10 o'clock, we'd be down there at 9 o'clock to start the warm-up process.
Yeah. So you had a position to put, I think you said 2 or 3 locos. So depending on whether it was 2 or 3, you had a starting position for each loco, I take it.
Yeah, the starting position was not important. If you told the computer there were 3 trains, it had to see 3 trains in the platforms. It didn't matter which platforms.
Okay.
Because the computer will work out the next move from the empty platform.
Mm.
But if that sensor was lit, it would throw an alarm because that is bad. If it was told it had 3 trains and it only saw 2 or 4 LEDs, then it would throw wobbly and throw the alarm as well.
So there's quite a lot of error conditions being tested in the sequence in the sequence pick then, the program.
Absolutely, yes. If anyone's interested, I could run through the lines of code. Any interest there?
Perhaps do that shortly. There's a question from Robert.
Okay.
I was going to say, how do you actually tell it how many trains it's got?
Right, there's a hex switch, hexadecimal switch, which is not shown on this picture. And there are 16 hex codes. And you can dial up a code and press the set button. And one of the codes is 2 trains, another one is 3 trains. Thereafter, you dial up either default idle state or run. Or indeed, you dial up run with public panel. So you could operate it with the public panel running or without it. So yeah, that hex code switch for 4 I/O lines on the PIC and a select button, 5 I/O lines, gave us all the configuration control that we needed.
Sorry, I was just wondering, how often does the layout run?
It only comes out for high days and holidays. So the Steam Gala, the Diesel Gala, the Thomas weekend, War on the Line, and events such as that. The Thomas weekend is a killer because it's 7 days of babysitting an automatic layout when there are thousands of children there. And I am slightly allergic to thousands of children.
Yeah, I was just going to say, there's a question from Roger.
Do you actually charge the punters to visit and play trains on this, or is it pure publicity for the railway?
It's pure publicity. It's owned by the Midlands Railway. It's there as an extra attraction, and no money changes hands. But there are signs saying you can buy engines like these at our shop, etc., etc.
Thank you.
Right, can you all see that?
Yes, we can.
Okay then, this is the C code. Crumbs 2011. So long ago, so long. Right, what's of interest in here? Somebody asked a question, what would they like to know about on the traction pick?
How does it decide which train is the next train to move then?
Right, this is the traction module. And
Oh, right, okay.
to do that, I need to switch over to the
No, that's
sequence.
fine. If this is a traction one, then obviously.
Yeah, I've got all three
All right.
highlighted here. I'll just switch over to the sequence pick.
Yeah.
Right, okay, so here we go. Where is it? Right, this is the key piece of code. This is called every time a move is about to start. It's got the OK from the control panel, from the public panel. And it looks at its variable called number of trains. If it's 2, then it goes through this switch and case statement and decides which movement number can be done. So remember the infrared sensors called IR something. So that's section 2, infrared 1. As it turns out, we only had 1 infrared in each section, so they're all ending in a 1. And if you've got that and that, then that's an OR. There must be some inversion going on somewhere. It'll return 4. I know this code works, so if you've got, right, bear in mind this is the case for 2 trains. If you've got IR2 and IR3, then it's going to run the next move as 4. So this code is called from the dispatcher. And here's the dispatcher.
Sorry to interrupt, is there a reason you have a bitwise OR rather than a logical OR there?
I can't remember. Well, they are bits. I'm looking at the IR port. The details of what my mind was thinking back in 2010 escapes me. Sorry about that. You can see here where there's 3 trains, then it's looking for 3 conditions to decide which train movement operates next. And if you fall right through this code, you return 0, which is going to set the alarm off. So here's the dispatcher. So it's doing get move number from positions, which is that previous piece of code, and does a switch statement and calls the move number. Or if it's none of the above, fatal error, sound the alarm and take a break. So if I look now at the move, let's say move 1 or move 4, yeah, move 4 here. So it starts by masking the narrows the view of the infrared sensors so that it's not bothered by the sensors which aren't required for this move. So this move, we're going from section 3 to section 4. And we'll be going around, can't remember now where the what the section numbers are. Anyway, we just narrow the view of the sensors. So basically we start by turning on the power.
Sorry, that goes around the right-hand loop. You have it there, line 654. You have it well documented.
Oh, okay. Wish I could read. Thank you. Yeah, so we turn the power on, and because we're going round the end loop, we don't bother with let's go to slow speed. We'll tell the traction pick to ramp up from 0 to medium speed. And we don't use slow because otherwise we'll stall on the curve. Then there are infrared sensors where we're preparing to come into the reception platform. When we get that sensor, we'll go to slow. To be tidy, we turn off the power to the section we've just left. And then we're waiting. So at this point, the speed is ramping down from medium down to slow. At some point, halfway along the platform, the locomotive will enter the slow speed mode. So the speed's ramped down from medium down to slow. And we're waiting then for the end of platform sensor when we can issue the stop command. We then wait for 2 seconds, I'll come on to that, and then we turn off the section relay. Okay, I can't remember why I've got that pause in there. It was obviously needed for something. No, it's escaping me.
Hi, Dave. Could I ask a wee question, please?
Yeah.
I've been getting to grips with the on the Arduino SIG and looking up at WSAG's presentations by Davy Dick. From what I see, it looks as if this could be presented as a pseudocode, and then that to be used to translate into any language based on what Davy's teaching. But it would seem to me also that this could be a very useful little exercise as a project on Arduino programming and controlling. Do you have any thoughts on that, Dave?
It would be very translatable to Arduino, apart from one thing. The physical interface to the I/O ports would be different. So there would be some changes needed to the functions. We would have to have functions, rather than accessing the ports directly, we'd probably need to change that to a function so we could gain access to the port. Would we? I mean, the port structure is going to be completely different on an Arduino from a 15-year-old PIC chip to an Arduino is a big jump. So the gotcha here is the actual physical interface to the ports.
Yeah, that makes sense, Dave. Thanks. It would seem to me, from what I've picked up in that relatively recent time, that could be taken care of in the way in which the pseudocode is written, and if the comments in the pseudocode part from pseudo to Arduino code, if the parts which refer to the ports, that could be included in comments within the pseudocode to help keep track of what's happening. Does that make sense?
Yes,
or
it
has
does.
someone
Yeah.
else got a better idea?
I'm quite prepared to put this code up onto GitHub, and I'll post the link to GitHub. Anyone can have a go at doing something with it.
Ron Plucked asked that question: would it be available? But if you give us the link, Dave, when you've done that, I could put that with the video so that people watching the video could then click away to see the link to the software.
Yeah, cool.
It'd be nice just to work their way through it, because you've got it well commented.
I don't believe in self commenting code.
No.
Although, if you took the comments out of that piece of code there, I think it'll still be readable.
Yes. Yeah. Well, that's one of the secrets of good coding, anyway, isn't it?
I hate to contradict an expert, Dave, but I would find it impossible to read. Cheers.
Oh. Right. I can't answer that.
I think Dave means it's logically readable. You might not know what the syntax means, but when you look at the words of how he's described his functions, it's quite explicit, isn't it?
I mean, to me, that says everything I need to know. The comment on that is that the turnouts are set as a byproduct of setting the direction. So
yeah. Thanks. That actually makes sense to me as a newcomer to coding. I think the point that was possibly being made in what I've come across so far is that by putting comments into your coding, it helps both you to remember what it was that you were thinking about at the time, but also means that somebody else can pick up your code and run with it if you happen to have fallen under a bus in the last 25 minutes.
Mm-hmm. Exactly. Yeah. Anybody want to see the traction pick? I was going there.
Yeah,
go for it.
Okay. Just looking at if there's anything else interesting. This routine here is quite interesting in that it's the communications with the public panel. And there's a whole lot of testing going on in here. And the communication between the two panels is basically a single ASCII character. So basically I took the ASCII chart and I said, what makes sense for communication? And I just chose a letter of the alphabet and assigned it to a use. G for go, A for acknowledge. And if you don't get the right answer back from the received character, then you sound a beep code. So this beep code is, it goes beep, 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 beep. And as an operator, you hear that and you know, oh, hang on, it's screwed up on the comms. Why it's screwed up in the comms, well, that's completely another matter, but fatal error, you saw that call somewhere. This sets stop, sets the error LED on. It informs the control pick that I'm broken, by sending X, and it looks at the hex switch, and if the switch is set to 7, or not set to 7 I should say, then it beeps a code. If the code was 3, then it would go beep, beep, beep. Yeah, that Arduino question, bits of code like this would need complete rewrites. Of interest, I use the EEPROM to store configuration data. So here it's storing the number of trains that are on track. So anyway, I'll put this up on GitHub, and you guys can, where should I put the link, Paul?
If you send me the link, I'll put it on when I upload the video. I'll put it on with the video, if you like.
Right, cool. Okay then.
What environment are you in at the moment, Dave?
I'm on the Unix laptop.
No, I mean, what are you reading? What's the soft when you put the file when you put the file up? It's just going to be a text file, is it?
It'll be a link to Midhants Railway
Just to
project
GitHub.
On GitHub. Yeah, it's just a URL.
Okay.
It'll take you out what you're looking at, the GitHub itself.
Does it have to be GitHub?
It's what I use.
Oh, okay, 'cause I hate it. I can't get around the GitHub. I'll have to learn how to use it. So.
It's what everybody's using now.
Yeah,
Rob.
I know, except me, of course. But okay, yeah. Also, Dave, what compiler do you use?
Compiler, well, back here I was using High-Tech C Pro Lite. These days I use the Microchip MP Lab X
Oh, okay.
IDE, and the default compiler that you get with MP Lab X.
That's XC8.
I had to think about that then.
Yeah, Roger's got a question. Dave.
Okay. One simple way of between the Arduino and the BICs as far as the I/O ports is you can, as far as the software is concerned, have all the I/O ports as virtual ports, and then you've got one routine that changes virtual to physical, and obviously that then is you've got the changes in just one place between the Arduino and the PIC or any other processor.
Yes. Well, that's what I mean about my code doesn't use such a mechanism. And so I've got the I/O ports dotted through this code because that's how I've always done it. But yeah, with a bit more power in the microprocessor, I mean, an Arduino AVR chip is running megahertz for megahertz 4 times faster.
Picking up on what Roger just said, and the beginner's Arduino yesterday, it would seem that it would be possible to set up, I think it's called classes, at the top of the Arduino program, which would effectively do, it seems to me, would do the translation. Or have I got that completely wrong?
Yeah, a class is as good as way as just writing a function. Just takes a few more lines of code to set up the class.
I must admit, I use that procedure with the AT-bus stuff that I'm doing. And it's only literally a few lines of code to translate from a logical port to a physical port.
Yeah.
In fact, on the C port, it's one line.
Yeah. So yeah, I've got literally all through this code, I've got physical port references absolutely everywhere. There's another port. Yeah, they're littered right through my code, physical port references. In the nicest possible way, they are either in defines or, well, they are in defines. So they are fairly easy to track down. They're not complete magic numbers. Yeah, I'm right down to the metalwork here, clearing the ports.
Dave, if you were implementing this control system today, what would you use? Would you still go the same way with writing a program for pick like this, or would you use something else?
Okay, writing it today, I wouldn't be using a pick, I'd be using an Arduino. I'd be using classes and all the C++ features of Arduino that the beginners don't see generally. I would probably set up a glass control panel. So the actual infrastructure of the electronics would change. I would probably do it on C-bus, etc., etc. Yeah, it would be quite different. At the end of the day, though, once you get past all that setting up of stuff, that function there will be nearly identical. What I'd have to do is put some changes in just there to get rid of the references to a physical port. And signal 52, for instance, would look more like that than what I've got it as.
Okay, thanks.
Yeah, Arduino and a decent bus like C-bus. And a glass screen, definitely a glass screen with probably a touch screen. The traction. Right, okay, you're done.
That's okay. I'll just say we're coming up to an hour and a half now, Dave, if that's okay. If you've got a little bit more to say. Can I remind everybody that the next meeting is on the 15th of December, and it's really just a training session for those that want to update the website, the wiki. It's if you want to add information but you don't know how to. A number of people expressed an interest in doing that through the poll, so we're running that short course, hoping to cover the basic stuff and the more advanced stuff. But if we don't get that far to the more advanced stuff, I'll run another session in January. So it's not a meeting per se, it's just really for training for those that are interested in learning a bit more about how to alter the wiki, edit it, add images, add text, and also play tunes.
Well, do you mean the 15th, which is a Tuesday, or the 16th, which is?
No, I probably mean the 17th actually. I just looked I was looking. It says 15th, but of course that's the date that the reminder email goes out. It's 2 days beforehand. It'd be the 17th. It'd be the Thursday.
Thank you. Paul, accept my apologies. I can't make that date anyway.
It's okay. I'm not expecting the large numbers of people to attend. It's just there's a few people who would like to obtain the skills to be able to add some stuff to the website, because basically this group will survive on everybody sharing what they know about different subjects. And just take an example of all the different controllers out there, the commercial ones. If you've got experience of those, you're the best person to add something. You know, I could go around and put all the stuff up about what the manufacturer reckons it does, but coming from each individual, we can put our own slant on that, say what works, what doesn't work, what the pros are, what the cons are, and we can give people proper advice then. So like for instance, I've never operated the Hornby software, not at all, so it would be silly for me to put that information up. Okay, so thanks, Dave. It's been quite an interesting journey. It was quite a feat 10 years ago, 9 years ago, whenever you started, and it's interesting to see how many picks you had to use. Were there not any larger ones out there, or they would? You said you mentioned that they were probably the cheapest, were they, at the time?
I believe I had some 877s in my toolbox at the time, so.
Yeah, right. Okay, so it's what was available. Yeah. Okay, then. We'll see. If I don't see everybody on the 17th, then we'll meet. The next meeting is in January. Okay.
Okay.
Thanks very much, Dave.
Thanks very much, Dave.
Say goodbye.
Thanks, Dave. Thank you very much. Thank you.
Thanks, Dave.